Hello everyone. Today, let's learn together about the construction of Loess and saline soil subgrade. Firstly, let's start with the engineering properties of Loess and the construction of subgrade. Loess is a kind of special soil deposited in terrestrial fissures under the arid and semi-arid climate conditions in the 4th century. As shown in the diagram, it is mainly yellow or reddish-brown, generally without obvious bedding, and exhibits vertical joints. In its natural state, Loess has a low moisture content, and the side slopes can remain upright, but they are prone to collapse when exposed to water, especially exhibiting a collapsible nature to form sinkholes easily. Loess has two major engineering properties: vertical permeability and collapsibility. Vertical permeability in Loess is much higher than horizontal permeability, and there is a significant difference in shear strength in different directions. At the same time, due to its noticeable collapsible nature, Loess is susceptible to erosion and scouring. According to collapsibility, Loess can be classified as collapsible and non-collapsible. For the construction of embankments in Loess areas, the following methods and requirements should be followed. 1. If the subsoil foundation base is generally constituted by collapsible Loess, measures should be taken to intercept and surface water should be drained to prevent infiltration. Underground drainage structures and surface drainage ditches must take anti-seepage measures, and water accumulation on the roadsides is strictly prohibited. 2. If the foundation base Loess has strong collapsibility or high compressibility, compaction or reinforcement measures such as rolling, dynamic compaction, lime pile compaction, and replacement should be taken before filling. 3. Roadbed filling material should not use old Loess and should not contain soil clumps larger than 100 mm of particle size. 4. Paving thickness should be controlled between 25 and 30 centimeters, with a moisture content lower than the optimum moisture content by 1% to 2%. 5. Use a roller with a tonnage of 18 tons or more for compaction. 6. During construction, the width of the white fill section on both sides of the embankment should be no less than 50 centimeters to ensure that the overall compaction of the subgrade meets the standards. As for the construction requirements of Loess cutting sections, the following points should be noted. 1. Loess cutting slopes should be excavated strictly according to the designed slope. If it is designed as a steep slope, construction must be slowed down to prevent slope erosion. 2. Loess cutting slopes are easily deformed due to various factors. Therefore, measures should be taken to protect and reinforce the side slopes during construction. 3. In cutting construction, if the geological conditions of the side slope do not match the design, the slope should be modified. 4. If excavation of Loess cutting is necessary to be carried out during the rainy season, efforts should be concentrated on rapid construction. The working surface should maintain a slope greater than 4%, and the lateral drainage ditch should be no less than 2 meters from the side slope. We have learned about the engineering properties and construction requirements of Loess above. Next, let's continue to learn about saline soil subgrade. Saline soil refers to soil with a soluble salt content greater than 0.3% in the soil layer below 1 meter from the surface. According to formation conditions, it can be divided into saline soil, alkali soil, and saline alkali soil. According to the nature and content of salt, different degrees of subgrade diseases will occur. Common types of saline soil subgrade diseases include erosion, frost heaving, and frost boiling. The image shows erosion a disease of saline soil. Erosion mainly targets chloride saline soil, followed by sulfate saline soil. After immersion in water, salt in the soil dissolves, forming rills, caves, and even slumping and collapsing. Another type of disease is frost heaving, as illustrated in the image. Due to the moisture content in the soil, freezing at lower temperatures causes the soil to freeze, increase in volume, and ultimately lead to swelling and deformation of the soil and damage to asphalt pavement. For chloride saline soil, when the salt content is within a certain range, it significantly lowers the freezing point of salt solution and increases the time for water retention, exacerbating frost-having damage. However, when the weather is warm and thawed in cold areas, saline soil subgrade will have frost-boiling diseases. It can be seen from the figure that the frozen soil beneath the pavement begins to melt, causing the subgrade soil to become saturated and soft under traffic load, resulting in surface cracking and the emergence of mud from cracks. This phenomenon is known as frost boiling, a disease of saline soil. To address different diseases, targeted treatment and improvement measures are necessary. In the battle against saline soil subgrade diseases, some teachers from Beijing Agricultural University have worked diligently for 12 years, living in 3 lake houses and eating dried sweet potatoes in Quzhou County, Hebei Province, and have finally found a remedy for treating saline land. At the International Symposium on Saline Soil Improvement in 1985, Professor Saboch, a famous soil expert, also praised that China's saline soil improvement work is first-rate. This shows that the spirit of hard work and research will never be outdated. When treating saline soil subgrades, the following construction points should be noted. Saline soil embankments should be filled and compacted in layers, with each layer's loose thickness not exceeding 20 centimeters, and sandy soil's loose thickness not exceeding 30 centimeters. The moisture content shall be strictly controlled during rolling, and it should not exceed 1 percentage point of the optimal moisture content. Construction is not allowed on rainy days. To prevent the transfer of salt and ensure the stability of the subgrade, the compaction of saline soil subgrades should meet higher requirements, reaching heavy compaction standards. In inland dry areas, when the pavement is made of asphalt concrete and cement concrete, closed separation layer shall be set at the lower part of embankment according to design requirements. These are the engineering properties and construction points of saline soil subgrades. In this lesson, we have learned the specific content of Loess and saline soil subgrade construction. I hope students can understand the engineering properties of these 2 types of subgrade soil and grasp the construction points. That's all for today's class. Thank you.